Okay, today we're going to be doing 4.9A1. We'll be comparing and ordering rational numbers. You're going to need a calculator for these ones here. So we just need to replace the blank spot here with a greater than, a less than, or an equal sign to make the sentences true. These are called inequality symbols. So 5, 6, well, you can put that in there on your calculator. 5 divided by 6. You get 0.833 or 0.83 repeating, 0.83 repeating. So I'm thinking 83 cents in my head. And I know that 1/3, 1 divided by 3 is 0.33 or 0.3 repeating. Well, 83 cents is bigger than 33 cents. So this one is greater. Maybe I'll do those down here in green. All right. The next one. 4/5, well, you can do 4 divided by 5, and you get 0.8. And this one is 9 divided by 10, you're going to get 0.9. Now, again, I encourage you to put the zeros on there because you're so good at money. You know that 90 cents is greater than 80 cents. All right, let's see. 6/9. Well, 6/9 is the same as 2/3, which is the same as 0.6 repeating or 0.666. Just put some dots there. And 4/6, well, I'm not sure what 4/6 is. Actually, I am, but let's pretend I'm not. But then I'm going to get the same thing. 0.666 repeating. It just goes on and on. So these two here are equal. 4/6 and 6/9. You can simplify them both down to 2/3. All right, 2/7. One more here. You know what? Let's go down and do one where, let's do number 11 here. We have 1 and 17/20. So we know we're going to have 1. We could separate that out as 1 and 17/20. So let's just do 17 divided by 20. 17 divided by 20. I think it's 0.85. It is. So this is 1.85. Think of what, $1.85. And this one, 1 and 8/10. Well, 8 divided by 10 is 1.8. Let's put the 0 on there so we can think about $1.80. Well, of course, this one is bigger here. Sorry, I forgot to do these in green. This one's greater. So you can work through those. They're pretty straight up. Let's do one more here, that number 12. 9 and 3/2. Well, this is a strange one. This is really the 9, and plus, let's do the 3/2. So 3 divided by 2. This is 1.5. This is 1.5. So really, this is 9 plus 1 plus 0.5. This is really 10.5 here. Now 9 and 5/6. 9 plus 5/6. Well, we just did 5/6 up top here. 5/6 is 0.83 repeating, remember? So this is 9.83. Well, just write it down here, 9.83. Of course, $10.50 is greater than $9.83. I guess I gotta slide that over. So let's take a look at number 18. Here, that's a semi-word problem. We have 7/10 of a gram, so that's 0.7. And we have 0.72 of a gram, 0.72. I know you automatically want to say, this one's bigger because it's got more numbers. In this case, it happens to be right, but put the same number of zeros on there, or add zeros so that both numbers look like money. Here's 70 cents and 72 cents. Now I can a lot more confidently say that. It's not always the bigger number. Okay, let's see. Determine whether each number here is rational or irrational, and write yes or no. Well, a rational number is a number that you can write as a fraction. Okay, and a real common example of a number you can't write as a fraction is pi. It's 3.1415, blah, blah, blah. Well, so this one here is already written as a fraction, 821, and therefore, this is a rational number, 821, 8/21. So this is rational, right? It's a fraction. This one here, well, this one here, let's see if it ever repeats. 0.505, 505, 55. It's not repeating. So when you have a decimal that doesn't repeat or doesn't terminate, this is not rational. This is not rational. Another way of saying that is irrational. I'd make a joke about one of my old girlfriends, but I'd probably get in trouble for that, so I won't. All right, this one here, 1.142857. Well, this repeats. What that really means is the next digits are 0.142857, 142,857. It goes on and on. That's what that bar means. So if it repeats, it is a rational number. It can be written as a fraction. And I could go through a long process to show you how to write that as a fraction. But because it repeats, I'm just going to say that it is. This is a rational number. All right, quick review. Rational numbers are things you can write as a fraction. Decimals that terminate or repeat are rational numbers. All right, good luck finishing that top of the page.